Hi guys, I am Divyan from IGCSE on Fingertips. Today we are solving 4-2 of ON 2022 for chemistry. Let's get started. So we have the first question. Diamond and graphite are different solid forms of carbon known as allotrophs. The carbon atoms in diamond and graphite are arranged in different ways. Okay, tetrahedral and hexagonal rings. State the number of covalent bonds each carbon atom has in diamond. So one carbon atom is bonded to four other carbon atoms in tetrahedral structure. So I will write 4. State the term used to describe the structure of diamond. The diamond structure is giant covalent structures, right? Giant covalent. Tetrahedral is shape, it is not structure, right? Giant covalent structure. So don't get confused between tetravalent, like tetrahedral. Tetravalent means 4 valency, tetrahedral means this pyramid shape of thing happening, and giant covalent meaning a huge molecule. Okay, name the oxide that has similar structure to diamond. Silicon 4 oxide, right? We have understood that silicon 4 oxide also has similar structure. Then part D of this question, describe, okay, describe the arrangement of atoms in graphite. So what happens in graphite is there are hexagonal rings. Okay, there is one ring and then it is attached to another ring. So sheets of rings placed one over another, right? There is another ring and then there is bonding between these molecules or these atoms, right? But I need to write it down, so let's erase this and let's write sheets, not only hexagonal ring, sheets of hexagonal ring placed on one another, right? Next, explain how graphite conducts electricity. Graphite, in these electrons between the sheets, those electrons are free to move, right? So I will write, if they are free to move, they are known as delocalized electron. So I will say delocalized electrons. Graphite structure is such that it has delocalized electrons. Then Buckminster fullerene is a simple molecular form of carbon. The relative molecular mass of Buckminster fullerene is 720. Determine the number of carbon atoms in one molecule of Buckminster fullerene. So one carbon is 12 gram, right? Relative atomic mass of carbon is 12. So how many carbons are there if the total mass is 720? So what can we do? 720 upon 12. 12 6 are 72 and 0. So there must be 60 carbon atoms if the mass is 720. All forms of carbon burn to produce carbon dioxide. Name the substance used to test for carbon dioxide. Lime water is turned milky by carbon dioxide. So my answer is lime water. Right? Carbon dioxide turns lime water milky. So that is the answer. Then we have sodium is a reactive metal. Suggest why sodium is stored under oil. Because it is reactive. But to prevent reaction with air, right, it will react with oxygen. Just a second. To prevent reaction with air, right, or it burns in oxygen. It reacts with oxygen from air. So I will write to prevent reaction with oxygen. Sodium burns in air to produce sodium oxide, Na2O. State the term given to reaction in which substance burns. Burning is combustion. The chemical term is combustion. So that is our answer. State the color of flame seen when sodium burns. Now, in the chapter in the chapter in the lab, right, there is a chapter dedicated to these type of questions. In that question, you will find flame test, test for positive ion, test for negative ion. I've also given these notes on our Discord server, so you can join that, get those notes, or by just from memory, the flame of sodium is yellow, right? In October, November, they have asked flame test in every paper, right? From 2023, what they are going to do is they are going to include these identity equations, right? The reactions in your paper 6, if you are giving paper 6. But here, you don't have that help, you don't have those answers. So you need to remember certain things, and those notes might help. Write a chemical equation for the reaction which takes place when sodium burns in air to form sodium oxide. So sodium burns in air, right? What is it reacting with? Oxygen of air to form sodium oxide. Now, how do I deduce formula of sodium oxide? See, sodium has a valency of 1, oxygen has a valency of 2. I cross multiply and find out that sodium is Na2O. Now I need to balance this reaction. For balancing, there are 2 sodium, 2 oxygen and 1 oxygen here. When balancing, you should first balance oxygen, then balance any other non-metal, and then balance the metal. So we have only oxygen and sodium metal. Balancing the oxygen, I must add 2 here. So there are 2 oxygen and 2 oxygen. Now there are 4 sodium, so I can add 4 here. This is how you should balance your reactions. Then we have the next question. Complete the dot and cross diagram to show the electron arrangement and charges of the ions in sodium oxide. Just a second. Okay, yes, sodium oxide. So sodium Na, right, has 8 electrons. It lost 1 electron from its outermost shell. Sodium is in group 1, so it has lost 1 electron in its from its outermost shell, right? So you have it has 1 proton more than electron, so it has a charge of +1. Oxygen has taken up those 2 electrons, so first I will show the 6 electrons that oxygen already had, and the 2 electrons, it took 1 each from sodium. We will show that by crosses. And because oxygen has taken 2 electrons, it has 2 electrons more than the number of protons in oxygen atom, and therefore the charge becomes -2. Next, we have sodium reacts vigorously with water to form aqueous sodium hydroxide, which is a strong base. Explain in terms of proton transfer what is meant by a base. Base is a proton acceptor. Acid is a proton donor. So I will write proton acceptor. Then state a pH number that indicates the presence of strong alkali. If it is strong, I will directly go for the highest possible pH. State the color of methyl orange in aqueous sodium hydroxide. Sodium hydroxide basic, methyl orange is yellow, right? Sorry, methyl orange is yellow. Okay. Then we have question number 4. So the equation for the reaction is shown. Sodium solid reacts with liquid water to form sodium hydroxide and hydrogen. Okay, yes. Calculate the concentration of sodium hydroxide formed in gram per dm cube, right? When 0.345 gram of sodium is added to 50 centimeter cube of distilled water. Assume there is no change in volume. So the volume of water remains the same even after you add 0.345 gram of sodium. Use the following steps. Calculate the number of moles of sodium added. Number of moles is equal to the measured mass upon the relative molecular mass. I know that the relative molecular mass of sodium is 23. Okay, so 0.345 divided by 23. You can use your periodic table here. You will have it on the last page of question paper. Determine the number of moles of sodium hydroxide formed. Okay, so if you use 2 moles of sodium, you form 2 moles of sodium hydroxide. So sodium hydroxide is also 0.015 moles. Calculate the concentration of sodium hydroxide in mole per dm cube. You have used 50 centimeter cube of distilled water. Okay, so I will need concentration is equal to mole upon volume. You can write n here, 0.015 upon volume we have taken is 50 centimeter cube. Now they want it in dm cube, so I will change it to dm cube by multiplying 10 to the power minus 3. So 0.015 divided by 50 into 10 to the power minus 3, that gives us 0.3. So the concentration in mole per dm cube is 0.3 mole per dm cube, but the question was asking us to find out in gram per dm cube. So determine MR of NaOH and calculate concentration of NaOH in gram per dm cube. So MR of NaOH, again Na is 23, oxygen is 16 and H is 1. So 17 and 23 will be 40 gram. So 1 mole of NaOH is 40 gram. There is 0.3 mole in 1 dm cube. So can I find out how many grams in 1 dm cube? Yes, I can say that if 1 mole is 40 gram, 0.3 mole will be equal to how much? That many grams are present in 1 dm cube. Simply multiply 40 into 0.3, which is equal to 12. So the concentration is 12 gram per dm cube. Then we have question number part D. When sodium hydroxide is added to aqueous iron chloride FeCl3, a solid product is formed. Name the type of reaction where a solid is formed from two solution. So precipitation is taking place, right? Sodium hydroxide reacts with iron chloride to form a precipitate. So precipitation reaction, right? It is a precipitation reaction when a solid forms. State the color of this solid product. For that, let's identify the solid product. So what is happening? Sodium hydroxide, right? So I will write Na plus and OH minus. These are present in the solution. Iron chloride, all chlorides are soluble. So Fe3 plus, because it is 3 chloride, and 3 Cl minus are also present in the solution. When these are reacted, what happens is sodium can react with chlorine and still stay as ion. Okay, sodium chloride is also soluble. But whenever iron meets OH minus ion, right, that is left out by sodium, they cannot exist as ion anymore. Their attraction pulls them together, they become a solid. That is what the precipitate is, iron 3 hydroxide. State the color of this precipitate. It is red brown, or you can say brick red. Okay, so it is red brown precipitate. Okay, then name this solid product. We already found out, iron. See, they are asking name, do not write formula. Iron 3 hydroxide. And write the Arnick equation for the reaction, include state symbols. I will write what happens. So Iron 3 plus was very happy existing as aqueous. OH minus was very happy also existing at aqueous. They met and form FeOH thrice, which is solid. And we are not happy because we are getting these kind of questions. So FeOH thrice solid. Okay. That is the ionic equation. Ions cease to exist. These two ions are not ions anymore in the solution. Sulfuric acid is manufactured by an industrial process. Sulfur is obtained from sulfur containing metal ores. Sulfur in the metal ore is converted into sulfuric acid and then oxidized to sulfur trioxide as shown. Okay, SO2 plus O2 gives SO3. Name a metal ore which contains sulfur. The metal ore that I know is zinc blende, right? ZnS. Zinc blende contains sulfur. Describe the process which converts metal ores to sulfur dioxide. Roasting in air, right? Zinc blende is roasted in air to produce sulfur dioxide and zinc oxide, right? So roasting in air. Then we have name the industrial process used to manufacture sulfuric acid. Contact process, right? Contact process is this. Only this part of the process is contact process. Then what do we have? The reaction that produces sulfur trioxide is an equilibrium. Yes, double arrows we saw. The forward reaction is exothermic. State the temperature and the pressure used to make sulfur trioxide. The temperature is 450 degrees Celsius. Okay, and pressure is 2 atmosphere. Right? Low pressure is used because this reaction is going forward anyway. Name the catalyst used. We use vanadium pentoxide or vanadium 5 oxide. Okay, then describe two features of an equilibrium. Let's describe them. The rate of forward and backward reaction is equal. The concentration of constituents once the equilibrium is reached, right? The concentration of constituents remain constant. So the rate of reaction is constant. The constituent concentration also remains constant. So you might not observe this change, right? This is a dynamic equilibrium. There is change taking place, but the forward and the backward change are cancelling each other out. Then we have state the effect, if any, on the position of equilibrium when the following changes are made. Explain your answers. So first let us write down what equilibrium do they want us to observe, right? This gives SO3, I believe 2 and 2 will balance 4, 5, 6. Yes, balances this, right? If you increase the temperature, forward reaction is exothermic. So equilibrium shifts towards left. Equilibrium shifts towards left. They are saying explain your answers as forward reaction is exothermic. Now, how do I know that equilibrium will shift this side if forward reaction is exothermic? Now, what happens is if the reaction is exothermic and you increase the temperature, this increase in temperature promotes the backward reaction or the endothermic reaction more than the exothermic reaction. So because the temperature is increased, both reaction rate increases, but exothermic reaction, let's say it becomes only twice, but endothermic reaction may become 5 times of the initial rate, 10 times of the initial rate. This will result in suddenly the equilibrium will shift a little bit towards the side that is endothermic, and here SO2 and O2 is endothermic, so equilibrium shifts towards left. Pressure is increased. Now if you observe, the number of moles on left hand side are 3 and the number of moles on right hand side are 2. So whenever you increase the pressure, the equilibrium tries to oppose your change. That is what equilibrium did in the first change also. But here, how does equilibrium oppose your change? You try to increase the pressure, equilibrium tries to decrease the pressure. How does it do that? By decreasing the number of moles. So if pressure is increased, the equilibrium shifts to right, because on the right hand side number of gaseous moles are less. Equilibrium shifts to right because of less moles of gases on that side. So if less mole of gases, less pressure exerted, and therefore equilibrium is trying to oppose the change. Then we have explain in terms of particle what happens to the rate of reaction when temperature is increased. So let's say you increase the temperature, right? So particles start to move, right? To move more vigorously, or let's say faster, and they and not they, let's write more particles have energy enough to react. Hence the collisions are more successful, or more number of collisions are successful, or more collisions are successful, increasing the rate of reaction. Okay, that's your answer. Name the compound formed when sulfuric acid reacts with ammonia. Ammonia is basic in nature, so it forms a salt, ammonium sulfate. Ammonium sulfate, right? Formula, let's also write formula just for you, NH4 twice SO4. Okay, let's see what do we have next. We have a new question. A student prepares magnesium sulfate crystals MgSO4 by adding excess magnesium to dilute sulfuric acid. Write the chemical equation for this reaction. So you have Mg. Let's first see how many marks this is. 1 mark, so no need to add state symbols, but need to balance the reaction. H2SO4 gives MgSO4 plus H2. This is already balanced. Describe two observations which show reaction has finished. No more fizzing, right? Because hydrogen was released. If the reaction is over, fizzing will not take place. No more fizzing. Solid does not dissolve anymore because this is going to be solid. So solid does not dissolve anymore. Only these two changes are observable here. Okay, you might add an indicator and tell that the color changes, and we know that reaction is over because sulfuric acid is over. Excess magnesium is removed by filtration. State the general term given to solid separated from a solution by filtration. If it is solid, which is not required, it is known as residue. It is the leftover solid from the reaction, right? It is known as residue. Then the aqueous, okay, let's read it now. The aqueous magnesium sulfate is heated until crystals begin to appear. Suggest the name for solution in which no more solute can dissolve. Saturated solution. So basically what they are doing here, they are trying to remove water as much as they can, right? Once they remove a lot of water, it reaches saturation point. So for that amount of water at that temperature, only so much magnesium sulfate can dissolve. So once that point is overcome, crystals start forming. Okay, so saturated solution. Okay, then suggest why more crystals of magnesium sulfate appear on cooling. When you cool, right, the saturation increases, right? The solution becomes more saturated, super saturated, because if you cool, the solubility decreases. So solubility decreases with temperature. So if solid can't stay dissolved, it will start forming crystals. Then we have next. Okay. Magnesium sulfate crystals having the formula MgSO4xH2O, where X is a whole number of molecule of water. Student heats the crystal to remove molecules of water. Name the term given to crystal containing molecules of water. Hydrated salt, right? Hydrated copper sulfate, hydrated cobalt chloride, hydrated magnesium sulfate, right? Hydrated magnesium sulfate. When we have the student heats a sample of magnesium sulfate, hydrated magnesium sulfate, and finds it has lost 0.140 moles of water and has 2.4 gram of magnesium sulfate. Determine the value of X. Use the following steps. Calculate the MR of magnesium. Sodium 23, magnesium 24, sulfur 32, oxygen 16, 16 fours are 64. So you have 64, 32, 24, 120. So MR is 120 gram. Try to include units if you find there are no units given. Determine the number of moles of MgSO4 formed. They are saying 2.4 gram of MgSO4 forms. So number of moles is measured mass upon relative molecular mass. So I have 2.4 divided by 120, which is 0.02 mole. Then determine the value of X in MgSO4. So if you observe, they said water was 0.140 mole is to, right, ratio of magnesium sulfate is 0.02 mole. So can I say for every 1 mole of magnesium sulfate, right, multiply it with 100 and divided by 2, I find that for every mole of magnesium sulfate, 7 moles of water will be there. Divide both of them by 0.02, you will reach the same answer. So the value of X has to be 7, because here it is 1, right? 1 MgSO4.xH2O. If that is 1, X has to be 7 every time. Then if student uses dilute nitric acid instead of dilute sulfuric acid, salt formed is magnesium nitrate. Write the chemical equation for reaction when solid magnesium nitrate is heated. Nitrates decompose on heating, that is their thermal decomposition. So magnesium NO3 twice. This heated produces an oxide, metal oxide, nitrogen dioxide, right, and oxygen. This equation is common for every metal except sodium and potassium. So you have magnesium oxide, nitrogen dioxide, oxygen. Let's balance oxygen. You have 6, 4, 5, 6 and 7. So I multiply half here. Sorry. No. 4 and 5. Right? So if I add 2 here, 4, 5, 6 and 7. Okay. I think here if we just and add half here. Now if you look, oxygen is balanced, right? 4, 5 and 1, 6. And nitrogen is automatically balanced, right? So that is your balance reaction with answer. In these type of reaction, do not forget to balance even if it is of 1 mark. Then we have question number 5. Ethane is an alkane which undergoes a photochemical reaction with chlorine as shown. Write general formulas of alkane. Alkane is CnH2n plus 2. State why this reaction is described as photochemical reaction. It requires light energy to occur. Right? Photochemical means it requires light energy to occur. Okay. In this reaction, an atom of hydrogen is replaced with an atom of chlorine. Right? State the name of this type of organic reaction. Substitution. Chlorine substitutes place of hydrogen. So the reaction is substitution. Okay, substitution reaction. Then in this reaction, one of the products is chloroethane. Name the other product. We just saw it was HCl. Name HCl, hydrochloric acid. Right? Okay. Then the energy profile diagram of this reaction is shown. Name the energy change labeled A. Okay, this is activation energy or energy of activation. Activation energy. We are trying to activate the particles so that they can react. Name the energy change labeled B. B is energy change of reaction. So I'll write energy change of reaction. Why is this the energy change of reaction and not total of A and B? Because the energy is changing only this much. This we have to give to the reactant so they start reacting. Okay. Then we have state how the energy profile diagram shows that this is an exothermic reaction. See, this is clearly an exothermic reaction because products have less energy than the reactants. What do products have? Products have less energy than the reactants. Then I'll just write reactants. Okay. Part F of this question. The equation for the reaction can be represented as shown. Okay, so you have ethane, chlorine, chloroethane, hydrochloric acid. Some bond energies are given. Okay, use the bond energies in the table to calculate energy change in this reaction. Use the following steps. Okay, first calculate the energy needed to break bonds. So what do we have? Instead of working it out here, let's work it out here. The energy required to break bonds. So I have CH bond, right? How many CH bonds do I have? 1, 2, 3, 4, 5 and 6. So CH bonds I have 6. Then I have carbon-carbon bond. How many? 1, right? I have chlorine-chlorine bond. How many? 1, right? So 6 multiplied by what is C and H? 410, right? Then carbon-carbon we have 350. So 1 multiplied by 350 and chlorine-chlorine we have 240. So 1 multiplied by 240. What is the sum of this? Let's find out. 6 into 410 plus 350 plus 240. So you have 3050 kilojoules of energy released. Okay, sorry, energy required for breaking the bonds in the reactants. I require 3050 joules of energy to break the bonds. Then what bonds are made? CH bonds are made again. How many? 1, 2, 3, 4 and 5. So 5 of them. Again I'll multiply 410 here. Then CCl bond is also made. So C and Cl, how many? Only 1, which is 340. So 1 into 340, right? Then we have HCl bond is made, right? That is 430. Only 1 bond is made. So 1 into 430. So I have 5 into 410 plus 340 plus 430. So just a second, guys. 1, 2, 3, 4, 5. Oh, I am forgetting carbon-carbon bond is also made again, which is 350 joules, right? So I have 5 into 410 plus 340 plus 430 plus 350. That is 3170 joules. Okay. So I require 3050 joules for breaking bonds, and I release, or the bonds release 3170 joules when they form. So 3050, 3170, let's write those values here, right? Obviously this has to be energy released in making bonds. Determine the energy change in this reaction. How do we determine energy? Energy released or energy required to make bonds minus energy released when bonds are made. So this is minus 120 kilojoule per mole, right? 120 kilojoule per mole is released in total when this energy change takes place. So that is an exothermic reaction. A carboxylic acid has the structure shown. State the general formula of carboxylic acid. The carboxylic acids are CnH2n plus 1 COOH. Okay, I think if there is only one carbon, you have C1, then you can't have COOH, correct? Let's write it in this form. CnH2n plus 2 O2, right? There are 2 oxygen always, or even better, you have double OH. Okay, so that's your formula. Name the carboxylic acid. Why? There is only one carbon, so this is methanoic acid. If you find organic chemistry difficult, we have made revision videos for this. You can check out our channel. You can check out the I button. Write the molecular formula of carboxylic acid. Why? So it is methanoic acid. So I have HCOOH. Right? That is how I can write the formula. It is methanoic acid, correct? It is. Okay. Then dot and cross diagram. Without reading the question, I'm sure it is dot and cross diagram. So carbon, they have shown by dots. So it shares 2 electrons here, 1 here. Okay, all 4 are taken care of. Let's talk about hydrogen. 1 here, one here. Okay, all hydrogens taken care of. Oxygen also has crosses because this is sharing two. Oxygen shares two. Six oxygen and 6 electrons in its outermost shell. 1, 2, 3, 4, 5 and 6. Same goes with this oxygen. 1, 2, 3, 4, 5 and 6. I think this is the whole dot and cross diagram. Hope it makes sense. Then we have carboxylic acid Y will react with propane 1 all. Okay, this is methanoic acid. Okay, C3H7OH to form an ester Z and one another product. Esterification reaction releases water. Name and draw the structure of ester Z. So it is propyl methanoate, right? Because propanol is the alcohol, methanoic acid is the acid. So we have propyl methanoate. Okay, the structure of propyl methanoate. So we'll first draw. We have to show all the bonds and everything, right? So we'll first draw the methanoate part, right? This is connected to oxygen to 3 carbon because it is propyl, right? Hydrogen, and total 7 hydrogen. You can draw it inverse also. You can draw first propyl and then methanoate. The answer is still correct. I'm just showing you a method. Name the other product formed. I just told you water is formed in esterification reaction. We require concentrated sulfuric acid for esterification to happen, but water is given out because sulfuric acid is a good dehydrating agent. An ester Z which is structural isomer of, name an ester which is structural isomer of ester Z. So we have propyl methanoate, methyl propanoate will be its isomer, methyl propanoate. There can be a lot of them, okay, because you have 5 carbon here, 4 carbon here, so you can have combinations, okay, but this is also a correct answer. Carboxylic acid which is structural isomer of ester Z. So carboxylic acid is also a structural isomer. How many carbon do we have? 4. So it has to be meth, eth, prop and butanoic acid, right? The total number of carbon from prop and from meth, I take that it is 4. This carboxylic acid with 4 carbon has to be butanoic acid, right? So that is our answer. Yes, with which we finish our paper. Let us know if we have solved your doubts from this paper. Let us know if you have any more doubts. Till then, keep practicing, keep scoring. Thank you for watching this video. Have a great day. Bye bye.